Welcome to The Whole Pineapple. I'm Ruby Booras.
And I'm Ann Judge. The Whole Pineapple is a podcast about wellness focused around fertility. We'll talk with experts on a wide range of topics, including nutrition, stress relief, sleep, mental health, etc.
And we'll dig into the issues that can cause fertility challenges, like PCOS, or early menopause, or cancer treatment.
So if you're curious about your fertility, whether you're ready to start a family,
or you're preserving your options for the future, let's dig in. Okay, and welcome back to The Whole Pineapple. This is Ruby Booras.
And Ann Judge.
And we have a very special, one of our last guests episode.
Saving the best for last.
Saving the best for last. Ann, do you want to tell everybody what we're talking about
Yeah,
today?
we're talking about the end of sex. I mean, that's something interesting to talk about at the end of our podcast.
And that sounds terrible.
I'm so excited about this guest because this is someone that I saw speak at a conference many years ago. And I found his whole talk and just the whole concept fascinating in terms of what it might mean for the future of our field. You know, we've already seen so many changes in terms of what's possible with IVF and what we can do right now in terms of testing of embryos. But his book was really a great analysis of what the future could look like and how there's a realistic pathway to assisted reproduction being the more standard way. And so we thought, what a great guest to have here at the end to share these thoughts. So we are very, very happy to have our impressive guest.
We are thrilled to welcome Hank Greeley, who is a Dean F. and Kate Edelman Johnson Professor of Law, Professor by courtesy of Genetics, and Director of the Center for Law and the Biosciences at Stanford University. He specializes in ethical, legal, and social issues arising from the biosciences, particularly genetics, neuroscience, stem cell research, and assisted reproduction. He is the founder and a past president of the International Neuroethics Society, chairs the California Advisory Committee on Human Stem Cell Research, and chairs the Ethical, Legal, and Social Issues Committee of the Earth Biogenome Project. For 6 years, until about August 2022, he served on the NIH Brain Initiative Multi-Council Working Group while co-chairing the initiative's Neuroethics Work Group. He is the author of The End of Sex and the Future of Human Reproduction and CRISPR People, The Science and Ethics of Editing Humans. Hank Greeley graduated from Stanford in 1974 and Yale Law School in 1977. He clerked for Judge John Minor Wisdom of the Fifth Circuit Court of Appeals and Justice Potter Stewart, then served in the Department of Defense and Energy in the Carter administration. He litigated at the Los Angeles firm of Tuttle and Taylor before joining the Stanford faculty in 1985. Welcome.
Oh, my pleasure. I love talking about this stuff.
Well, tell us just a little bit first about, your background and how did you get interested in this area and what made you decide to write this book?
So I'm a lawyer. Actually, I'm a recovered lawyer. I haven't been a lawyer for 38 and a half years, though I still keep my bar membership. I don't know why. I'm a law professor. I ended up getting into this the same way most people get into things, sort of time and chance. Went on a blind date with the sister of one of my fellow lawyers who was a doctor, and everything sort of followed from that, one way or the other. But ultimately, I started teaching health law because I was married to a doctor. I thought I was going to do health policy work, which when President Clinton was elected was going to be really exciting. We were going to get universal health care.
That's when I was at Stanford as an undergrad, and my major in human biology was health policy. And so I was at my DC internship, and we were all like, this is going to happen. It's going to be so amazing. And then the world didn't turn out the way I thought it would.
It was so exciting. And I actually mainly blame Newt Gingrich. But in any event, it meant I wasn't going to be doing anything exciting in health policy for a long time. Happily for me, the Human Genome Project had just started, and I got pulled into doing some law and ethics of genetics work, which then led me ultimately through the birth of Dolly into cloning and embryonic stem cells. I added neuroscience to my repertoire in 2002. But throughout it, there was this nagging background of assisted reproduction, particularly through the genetics, but increasingly through some of the other areas as well. And so I began to think about, write about, talk about some of the assisted reproduction issues. Oddly, I actually know exactly when the idea for this book came.
When was it? What happened?
October 19th, 2010. I was at a meeting in Münster, Germany, which isn't the Münster the cheese is named after, but it's a different Münster, Germany, on stem cells. And a friend of mine who was then at Northwestern, Lori Zoloth, a religious studies bioethics person, was talking about the then fairly newly discovered induced pluripotent stem cells. The way you could take skin cells and turn them into these things that looked all the world like embryonic stem cells. And she was talking about the possibilities of using these iPSCs, little I, capital PSC, induced pluripotent stem cells to make, heart cells and brain cells and liver cells. And then she said, and what will happen when we can use them to make eggs and sperm? And then she went on to something else.
Just to leave that right there.
I didn't. I kept thinking, well, what would happen? I need to think about that. And I thought about that. And then I thought, well, there's probably at least a blog post here and maybe an article. And the more I thought about it, the bigger it got. It took me almost 6 years from that date to get the book published. It actually only took me 6 months to write it, but it took me 6 years to find the 6 months to write it.
Yeah.
And it really all stemmed from that question. What happens when we can make eggs and sperm from skin cells? The end of sex and the future of human reproduction is my 2016 effort to answer that question. We're now 7 years on from 2016. And there are a few things I might say a little bit differently, but by and large, I think the book's vision of the future may well turn out to be pretty accurate.
Yeah, that's why it's actually pretty interesting to get to talk to you now, as opposed to just like right when the book came out, because I feel like we have the ability to look back and be impressed by a lot of the trends that you were predicting. It's interesting. Again, I know you talk to people all the time, and you probably don't remember me at all, but I think when you spoke at the conference, it was at Start Out in Vegas, and I think it was before the book even came out. And I came up and talked to you afterwards because this is something that I have been thinking about, but within the setting of like a fiction novel. I thought it'd be really cool to write like a modern Romeo and Juliet, where you'd have like, many people being conceived via ART, but then you'd have this kind of underclass potentially of those that were still quote unquote naturally. And what would this be? And would the two groups like each other? And so I'd always thought that'd be a cool novel to write. And I was like, oh my gosh, someone else is actually thinking about this from the realistic side. So
I would have said that I didn't remember you. But I remember that Vegas convention. I remember somehow you guys found a hotel in Vegas that had neither smoking nor gambling.
Yeah, we were way off.
That's impressive, actually.
And I remember somebody coming up afterwards and talking about a science fiction idea.
Yeah, that was me.
I would not, you look not a day older.
Oh, thank you.
I would not have been able to put a name to it, and I didn't realize it was you until you talked just now about the science fiction book, but I do remember that.
Yeah. Well, that's fun. Yeah. Well, part of when we were doing this podcast, then you're trying to think, who would you like to talk to? I was like, oh, I want to talk to the end of sex guy. And then I've seen you since then at ASRM. And so it's a real honor for me to get to talk to you in this official capacity.
The end of sex guy.
That's not what you want as the epitaph.
The end of sex guy. I'm 71. Anyway.
How did you come up with the name for the book?
Well, there's a story to that, too. It was fairly early on, probably in 2011. I was writing a book proposal, and my wife and I were having dinner with our best friends on the faculty, my colleague Buzz Thompson and his wife Holly, just the four of us in their backyard, and I was describing the book. Yeah. And I said, I need a title. And so we threw some titles around, and then Buzz looked up and said, how about The End of Sex? And our wives both immediately said, that's wonderful. What a great name. And Buzz and I looked at each other and wondered, what were we doing wrong?
It's a great catchy title for sure. It gets people drawn into what might seem like a dry scientific topic.
It does, although I do often when I'm giving talks about it have to say quite quickly, my firmest prediction, my clearest and most confident prediction in the book is people will still have sex in 30 or 40 years. They just don't do it nearly as often in order to have babies. They'll do it for all the other good, bad, and indifferent reasons we do it.
Can you give us kind of the elevator speech style summary of like what are the main drivers that you're talking about in the book where you think it would be conceivable that sex would be more for fun and pleasure as opposed to reproduction?
So why would anybody write a book called The End of Sex? Back in 2007, a Japanese scientist named Shinya Yamanaka figured out a way to basically take skin cells and turn them into things that look like human embryonic stem cells. this is important because human embryonic stem cells can make every cell type in the human. How many cell types does a human have? It depends on who you ask. The estimates go from 200 to 200,000. Depending on whether you ask a lumper who thinks things are all the same or a splitter who thinks everything is different. We have unusually good reason to know that human embryonic stem cells can make every cell type in humans, however many there are, because that's what we are. All of our cell types have to come from human embryonic stem cells because that's what made us. Handful of cells in the middle of the little hollow soccer ball that at 6 or 7 days is the embryo that eventually becomes us. Those cells in the middle, called the inner cell mass, become our bodies. And they do that over time. They can become skin cells and hair cells and eye cells and liver cells and lung cells and eggs and sperm. Well, what Yamanaka did was figure out how to do that without actually having to destroy embryos, without actually taking cells from inside an embryo, but instead taking skin cells and hitting them up with some genes that turned them back in time, that made them undifferentiated, that made them able to become every cell type. And that's what he called induced pluripotent stem cells. And in a world filled with acronyms, that has its own acronym. It's a little I, capital P, capital S, capital C. These iPSCs seem to be able to make every cell type. Well, if you can make every cell type, eggs and sperm are cell types. So point one in the end of sex was, at some point, we're going to be able to take skin cells and make eggs and sperm. So far, we haven't been able to do that with humans, but it has been done with mice, and it's given rise to living mouse pups, living healthy mouse pups. Not always healthy, not healthy at a rate we'd be happy with for babies, but still proof of principle it can happen.
And I think that's the big thing for any of our listeners that have done or are completing IVF, the thought about the fact that what it takes right now to get your body to maybe grow 10 eggs in terms of the weeks of injections, the surgery to retrieve them, the high chance that even with that, you may not end up with any embryo to actually transfer. If you had that ability to somehow produce 100 eggs without having to go through all of that, I mean, you can imagine how that would completely revolutionize what we do.
With a biopsy compared to 2 weeks of injections and ultrasounds. And
it's not even really, I mean, yes, it's a biopsy, but it's a 2 millimeter punch biopsy. 2 millimeters is about 1/12 of an inch. It just takes a Band-Aid. There's no stitch. There's no nothing. And that's really point two. So point one is you could take skin cells, make them into eggs and sperm. Point two is that changes the world because it makes IVF or ART or all the various other abbreviations we can use, acronyms we can use, it makes it so much easier. Probably 70% of the cost of IVF and 98% of the discomfort and 99.9% of the risk is an egg harvest. I hate to say this, but this is one of those areas where men have an advantage. Sperm harvest has almost never sent a guy into the hospital. And people usually don't complain about the pain and discomfort of sperm harvest. Egg harvest is, by all accounts, not fun. We know it's expensive. We know it's unpleasant. We know there are some risks. A non-trivial percentage of women who go through egg harvest end up hospitalized as a result. Every once in a while, somebody loses an ovary. Every once in a while, every few years, somebody dies as a result of it. You know, your chances of dying are probably greater walking across the Stanford campus during a period of time when the classes are changing and the undergrads are madly biking.
All those bikes. Yeah, the clock tower is still particularly scary.
Yeah,
so, yeah.
The circle of death.
Yep. They put in all the signs. I saw at my last reunion. They're trying to direct traffic more, but it was still scary.
They're trying. So it's not a big risk. But if you could avoid it, why not avoid it? And so one thing that does, it makes it cheaper, easier, less risky, less unpleasant. That will mean that more people should be able to use it. And that goes in two different directions. The big thing with making eggs and sperm, and our crypto-Orwellian acronym for that is IVG, in vitro, meaning in glass, although it's actually done in plastic. Gametogenesis, meaning making gametes, gametes meaning eggs or sperm. And by the way, in theory, you could use it for sperm, but the real rate limiting factor in ART is eggs. It's not sperm, for the most part. So IVG does two things. It gives a chance to have babies that are genetically from the two parents to thousands, tens of hundreds of thousands. It gives a chance to make genetically related babies to millions of parents around the world, millions of prospective parents who can't make babies because they don't have the right combination of functional eggs and functional sperm. This may be because of disease. It may be because of accident. That's one way, by the way, where life is unfair in the other direction. We guys keep our gametes in a very dangerous position. You women have yours nice and safely tucked away. It could be you were kicked in the balls once too often when you were before you went through puberty. It could be because you had mumps. It could be because of a congenital problem.
Yeah, it definitely seems like a design flaw, but whatever.
But the end result is there are a lot of people who would really like to have kids, but they can't because one of them doesn't make eggs or one of them doesn't make sperm. Mm-hmm. And, there are two ways of looking at that. That's a great source of human suffering. And I have philosophers tell me, oh, not having a baby, that's not suffering. Babies are options, and having a genetic baby you could adopt, you could do this, you could do that. And it's one of the many things that I find annoying about philosophers. It's nice for you guys to say that, but like 80% of the world really wants this. If they think they are suffering, if they act like they are suffering, if they seem to be in pain, well, I'm not going to tell them, oh, buck up. It means nothing. Don't worry about it. This gives them an opportunity. And of course, one of the big groups in that category who don't have viable gametes are older women or don't have enough viable gametes. So I think the real reason to do this, to do IVG, will be so that more people who want to have genetically related children can. When they can't right now because one of them doesn't make eggs or sperm. There are a couple of variations on that, the most interesting of which is maybe they make eggs and sperm, but maybe both of them make eggs. Or maybe both of them make sperm. And so if you could make not just eggs from a woman's skin cells, but sperm from a female skin cell, or not just sperm from a male skin cell, but eggs from a male skin cell, why would you want to do that? Well, ask gay and lesbian couples, many of whom would really dearly like to have a child that was genetically half from one of them and half from the other. The same Japanese scientists who first brought us IVG mice, Mitanori Saito, and I can never remember his first name, but his last name is Hayashi, succeeded in early 2023 in getting mouse pups made from mouse sperm, obtained, I think, the old-fashioned way, whatever that means in a mouse sperm context. Yeah. There's some things I don't want to think about too much, and that's probably one of them. And then mouse eggs made from a skin cell from a male mouse. They were able to make eggs from a male's cell. They have not yet been able to make sperm from female cells, but they're working on it. So that's another potential set of people who really want to have babies. This will let them have genetic babies. This in no way says that adoptive parents aren't real parents or adoption is a bad thing or anything like that. But lots of people, for reasons that may be good, bad, and different, want to have children that are genetically from both of them. This will allow millions of couples around the world to do that. I think that's a good thing. But it doesn't end there. And that's where we get into item 3. So item 1 was being able to make eggs and sperm. Item 2 is how it changes the ability to do IVF and makes IVF so much easier and expands the potential number of people who can use IVF. I mean, IVF can't really do anything for you if you don't make eggs or don't make sperm, other than let you use donor eggs and donor sperm, but it can't get you a baby right now that is genetically 50% you. With this, it could. But point three is it allows you to do a bunch of other stuff, including increased use of pre-implantation genetic testing. PGT, also known as PGD, is the process of taking an early embryo, taking a few cells off of it, genetically testing those cells and saying, that embryo would grow up to have Huntington's disease. That embryo would grow up to have a very high risk of breast cancer. That embryo would grow up to be male. That embryo would grow up to have light-colored eyes. All of those are the kinds of things you can test for using PGT. PGT sounds like science fiction to most people that I talk to about, but the first PGT baby was born in 1990. I actually talked to Jacques Cohen, the IVF director whose clinic that was done at. And he's very proud. This was about 2 years ago. She's now a scientist somewhere.
Oh, that's so cool.
Wow.
But she's over 30 years old, right? So it's been done hundreds of thousands of times. It's been greatly increasing in use in the United States. Just in 2015, it was about 8% of IVF cycles. It was used in about 8% of cycles. Now it's being used in more than half, and in many clinics, particularly on the coast.
It's mostly the norm. It's always a little surprising when you have someone going through that you realize is just doing old school, just going to put in the embryo that looks morphologically the best on day 5, and then just hope for the best.
The one that's roundest or has the lightest color or whatever secret sauce that particular clinic thinks. So this makes it a lot easier to do this, to make embryos, because you don't have to go through, you still have to go through IVF, but you don't have to go through egg harvest, which cuts out so much of the expense, the hassle, the unpleasantness, the risk, and so on. And the other secret here, by avoiding egg harvest, if you do egg harvest, you will get somewhere between 25 and 0 eggs most of the time. And even if you manage to convert a high percentage of those to embryos, you may have 0 embryos, you may have a bunch of embryos, but you don't know. If you make eggs from a cell line, if you make eggs from skin cells turned into iPSCs, turned into a cell line, turned into eggs, how many eggs do you get? How many eggs?
As many as you want.
How many do you want?
Yeah.
Tens, scores, hundreds, thousands, potentially millions. So, in this third phase of the end of sex, I argue that many people will want to use this IVG, in vitro gametogenesis, making gametes, mainly, usually eggs, and use it to make lots of embryos. Use it to make 100 embryos. And each embryo will then get its whole genome sequenced. Something that used to cost $500 million now costs $1,000, will soon cost $200, and in 20 years will cost very little. And then they will be asked, so what would you like to know about these embryos? And the clinic will tell them what they want to know. Do you want to know about early, nasty, awful genetic diseases? Do you want to know about other genetic disease risks? Do you want to know about cosmetic traits? Will the embryo be lucky enough to have hair that turns white early in life? Tall, short, all those sorts of things. Most of which we don't understand very well now, but we should understand better. I mean, we can already tell light hair, light skin, dark skin, light eyes, dark eyes, but we can't really tell the shades of light or dark yet, but we will be able to.
That's one of the things I thought was so fascinating in your book, is you give that example of just imagine if you only had 5 embryos to choose from, but you had all of this information. Because you start with 100, you're going to knock out the ones that are at a high risk of, like you say, an early onset genetic disease, but you're still going to be left with ones where maybe there is a slightly higher risk in the future of something that is more manageable, adult onset, or it's still not destiny in terms of having that. And so how would you choose between the embryo that might be a little more athletic, but maybe has a slightly higher risk of schizophrenia? Or do you want to choose the embryo that might have higher SAT scores, but would have a risk of heart disease? And all this information, even if you only had it for 5 embryos, seems overwhelming to try and pick. And I mean, back when you wrote the book, I wasn't as common. But now I feel like this would be just where clinics would use AI. So you wouldn't even be putting this on the patient to choose. You would be plugging all this information into a computer, and then it would tell you this is the embryo that all things considered is the quote unquote best.
So Anne, you're taking this more dystopian than I thought about. I hadn't thought about AI.
This is my novel, right? That it's like you won't even get to choose. This will be like, yeah.
Is this because we talked about AI in our meeting today?
Maybe, but I feel like that's the logical conclusion, because that's what's overwhelming is if you have all this information, how do you weigh it in and of yourself and your own personal values? And you could see where people would just take that decision out and say, well, this is the one that we recommend, or potentially the one that we require if this becomes more of a regulated system. So
that's a really interesting thought. I think for some things, if you came up with a metric that you'd agreed upon for, say, health, and although this itself is controversial, there are quality adjusted life years, which would say like 2 years as a paraplegic is worth 1 year as a healthy person, et cetera. And you said, okay, based on what we can tell about these embryos' future, which will only be a small percentage of their actual health futures because much of it will still be chance or at least not genetic.
Right.
Here's the embryo that has the most quality adjusted life years. But that doesn't necessarily mean that's the embryo that parents would want, because there are no particular quality adjusted life years associated with being tall or short, or being light hair or dark hair.
Musical or athletic.
Right. I don't think parents would likely opt for that, except maybe on the health issues. But even then, it may be that on a quality adjusted life year basis, an embryo at a higher risk for Alzheimer's disease might look better than an embryo that didn't. But if you had a parent who died of Alzheimer's disease, that might be really important to you to try to avoid it. In the second edition, which will probably never happen, you're going to get credit for a footnote on another dystopian vision of this.
Perfect. And when I retire, if I do write my novel, I can credit you too.
Excellent.
So we'll shout each other out.
Well, it just shows that this conversation can go in so many different ways from here.
Right. The other couple of things parents might be interested in is a little bit about behavioral traits. There are some associations with things like extroversion, introversion, neuroticism, SAT score-taking ability. I won't call it intelligence because I don't know what intelligence is, but I know what SAT scores are. Math ability, musical ability, those things. They all have some genetic connections, but they're really weak. I think they're likely to stay weak because brains make genes look simple.
Mm-hmm. Yeah.
And genes are not simple. But brains are not simple to the 10th power. And then the easiest thing to tell a parent is boy or girl. And parents will get their list of 100 embryos and with the characteristics they were interested in, and said, okay, which ones do you want us to move? Which ones do you want us to freeze for possible future use? And which ones do you want us to discard or donate to research or donate to snowflake adoption or dispose of in some other way? So that's the third big driver. That's when IVG becomes used to lead to easy PGT, and parents start using it to pick embryos. That's what I think actually is going to become the norm in many countries that have good healthcare systems.
I really like the way that you organize the book into kind of those three big sections.
Anne and I love organization, and we really liked the organization of this book.
Well, and especially it's very impressive to hear that you wrote it in 6 months, because what I like about the organization is in that part one of the science, you give people an out if they either don't feel like they need a review of all the details, or maybe if that part isn't as interesting, if that part's kind of overwhelming. You do an excellent summary in the first couple pages of, hey, here's the big picture view of what is involved in IVF and how are we currently putting eggs and sperm in embryos, and kind of what is the basic you need to know to understand where we might go in the future. And then you're kind of like, and now you can skip the next 80 pages if you want to. So was that something you always intended to do, or was that something the editor suggested?
The editors on this one really didn't suggest very much. It seemed to me like a good idea because I figured different people would come into this with both different amount of background and different interest. My guess is it probably didn't help the sales of the book, because I think a lot of people picking it up and seeing the first 6 chapters are about science might have been turned off. But I'm really proud of those pages, because with all humility, which whatever little that is, I thought I did a good job of explaining stuff. I kept thinking about my sister. She's bright, educated as a lawyer, never really cared about or very interested in science. I was trying to explain it to her, and I think it worked.
And I think it's great to have someone write it who's non-medical, because I think you do have more of that view, and you're not going to just toss around terms that mean nothing to people outside of people that already work in REI.
I think that's a great point. And, if you read stuff I write about law, it is more likely to be filled with jargon, because that's my second language. Biology and medicine are not. And so I think I have a better jargon detector. I'm better at understanding, oh, wait, real people won't know what that means. Whereas res ipsa loquitur, strict scrutiny, constitutional originalism, those roll off my tongue, and I don't even stop to think that most people have no idea what I'm talking about.
Well, any of those language shifts are really interesting too. Like reading the book, I like that you called it, what did you call it again? Easy PGT? Was that, oh no, PGD back then, right?
Yeah, I was back in the D days.
So that was the other thing that's shifted. Like back when we first started, we did call it pre-implantation genetic diagnosis. And then we realized, gosh, like diagnosis is a pretty big word to summarize what's actually there. And so then we changed to pre-implantation screening, and now we often call it pre-implantation genetic testing for aneuploidy tests. So we just keep making it a little longer.
Adding a letter here or there.
Yeah, add a couple letters.
Little a, PGT, little m, PGT, little s, PGT, blip, blip, and blap.
All of the above.
I still have a tendency to call it PGD, although if I'm thinking about it, I will just call it PGT and leave the lowercase letters after the T alone.
But the reason there is, I think, so much more uncertainty than we realized, And even now with our testing, it really upended the field, this discovery of how much mosaicism played into it. And so if you're a listener and you're like, what do they mean by mosaicism? Please go back and listen to our earlier episodes with Rachel, where she explains what is mosaicism and what do we know and not know.
That's our genetic counselor.
Yes, our genetic counselor. For those of us that have worked in the field for a long time, it is weird at a conceptual level to think about all the embryos back in the day that were discarded because they were quote unquote abnormal. And now realizing that if we'd set that threshold for how much of material tested had to be perfect a little bit differently, that might have been something that we would now consider a mosaic of a level that we would transfer. So we are continuing to evolve as a field so much, even since you wrote the book. And that's what makes it seem really conceivable that we could go to the place that this book theorizes.
Although I will suggest, if you're interested in mosaicism, you can also look at some of the first 6 chapters of my book.
That's true.
Yeah.
Although it doesn't talk about that particular issue, which, that realization has been creeping up on people for a while.
Yeah. Definitely the last few years, mosaicism is kind of like the big catchphrase in a lot of conferences and stuff.
So for those of you who don't know what we're talking about, you can have an embryo that you test, and you'll see that some of the cells you tested have the wrong number of chromosomes. Often such a wrong number that there's no way it can turn into a living fetus. Except every once in a while, they do turn into living fetuses and living healthy babies. And we don't really know whether it's because most of these cells come from the outer part of the embryo, which don't actually become your body. They become the placenta and so on. Well, maybe the ones on the inside were all fine, or maybe the ones on the inside had both the bad cells and the good cells just outcompeted the bad cells. There's a lot we don't understand about many things, including especially human embryonic development.
What about other things that have changed since you wrote the book? You mentioned whole genome sequencing as being one of the kind of 3 drivers that might lead us towards this path of reproduction in the lab being the preferred method. And you mentioned in the book, initially that first human genome project, we're talking about it costing around $500 million, and then they'd gotten that down to being less than $5,000. Do you have any idea kind of what the cost is now, or what percentage of people and just the general time are doing this? Is it still mostly just within a research setting?
So on the whole genome sequencing side, leaving aside the question of are you really sequencing the whole genome, which you almost never are, but you're sequencing probably almost all the important parts of it. The price is now around $1,000, $800. Illumina, the monster in the field, the dominant market player, has said it's got new technology that it thinks will bring the cost down to $200.
Wow.
Wow.
In the book, I suggested that this was going to become available clinically in 20 years or so, which leaves me 13 years to go. I think that from $200 today, 13 years from now, it's going to be a very, very small dollar amount, maybe even less than I anticipated. So I think that's going to make it a lot bigger. People have still been slow to move into it, in part because it's not yet $200, it's still $1,000. And if you want to get a clinical grade genome that they're confident enough is accurate that doctors are willing to rely on it, you're looking at $4,000 or $5,000. If you want to do it with just a couple of cells, as you usually would in PGT, that's currently more expensive as well. So we're not seeing whole genome sequencing being widely used yet in most contexts, but as it gets cheaper and as we get better at doing a small number of cells and the micromanipulations that are required, I think it's going to become more and more common. The interesting question will be, at what point does the added information you get from whole genome sequencing become useful enough to outweigh the additional hassle and just the additional amount of data that you get that you've got to figure out and do something with, given all of the uncertainties that we are finding as we look more into genetics. I occasionally get a little bit pessimistic, though I'm fundamentally, I'm a very optimistically pessimistic guy. The closer we look at almost everything, we keep thinking as we understand more, things will get clearer. It's really complicated now, but it'll get clearer. And what seems to happen is it's really complicated now, we understand more, and now it's complicated at a different level. Mm-hmm. Mm-hmm. It's like fractal numbers, it just gets more, it stays the same level of complication, you just move down a level. I'm optimistic in that I don't think it's turtles all the way down. I think at some point we really will begin to understand it more. But certainly we can do whole genome sequences. We don't understand whole genome sequences all that much better than we did 5 years ago or 10 years ago. And, part of me thinks that's a good thing because it makes issues like super babies less important. If we don't know the genetic variations for, quote, super babies, close quote, we don't have to worry very much about them, about people getting them. But it's also very frustrating because basically every disease or condition seems to have some genetic component, but figuring out what it is and how it relates is proven to be very difficult, proven to be much more difficult than people thought a quarter of a century ago, and even more difficult than people thought 10 years ago.
Well, yeah, you do a great job of laying out in the book from like a societal level. I mean, there's a benefit, especially in countries unlike the US, where everything is not public insurance. If you have a government that's taking care of the healthcare of its community, you have a very strong incentive to not only avoid childhood diseases, but wouldn't you want the lower risk of heart disease at a population level? Or, it opens up the possibility. But I think your book also does a great job talking about how do you prove the safety to move forward with something like this. You mentioned the mouse pups. I mean, there were a lot of mouse pups born to be able to get a small number, and what would be considered safe enough in humans. And I think the other reason I remember you speaking at the conference is this is before Louise Brown turned 40. And you mentioned how, for all we know, all IVF babies drop dead at 40. And I was like, she is not 40 yet because she and I have the same birthday and we are not 40. So, but even now, like we're talking about, for all we know,
you were born on the same day as Louise Brown.
I was
not the
day.
Same day, but the same year.
Okay.
Ruby's the same day in a different year. So we both have our Louise Brown connections.
So if we add the two of you together, you're Louise
Correct.
Brown.
Yeah, but it's true. We don't even have 50 years of safety data yet on IVF. And there's no reason to believe that you're going to have long-term health conditions in old age or anything different, but we just don't know yet. And so if you were talking about something as new as induced pluripotent stem cells, what do we do? Would we have to follow children for a year, for 5 years, for 10 years? What would we decide looks safe enough to actually roll this out?
That's a problem. But it's a problem with everything new. One of my favorite examples, I mean, you can never say that a new drug is safe. You can say it looks reasonably safe. There was a morning sickness drug, not thalidomide, but a morning sickness drug in the 50s and 60s called DES. Worked well for morning sickness. Didn't seem to be any problems until women who had been at a certain stage in fetal development when their mother was pregnant with them, and when she took DES, they hit their 20s and they started getting reproductive tract cancers at an astonishingly high rate. You'd only find that out if you followed these people and their children for 20, 25, 30 years. So we're never going to do that. You pick a time that you think is reasonable. I think one thing that our society in general grossly underinvests in is monitoring. And frankly, I think IVF is a sad classic example of that. I wish that every IVF baby had been treated as a research subject and that we actually had good health data for all IVF babies. It is obvious so far that apart from issues around multiple births, which were certainly more common, especially in the early days of IVF, there's no real gross health differences. There's no huge difference. But are there subtle differences? We just don't have the sort of data that you would really want to have in order to be confident about that.
As an IVF parent myself, I understand how people don't want you to have that
Sure.
data. You feel very private about this, and it was already hard, I think, for most people to have to use science to create their families. So the last thing that people want to is to feel like their child is a science experiment for the rest of the world to look at. So I could see why there have been many reasons it's hard to get any kind of long-term registry info.
Including legal reasons, under the common rule, you can't keep somebody as a research subject when they went out.
Yeah.
But I do think it might seem a little different if everybody is being monitored and followed for this rather than just your baby. If the whole culture... But of course, part of this is such different cultural issues around health. In Scandinavia, disease registries are hugely common.
Oh, yeah. That's why all of our data and birth info is often from other countries, because they track it. They track it so much more than we do.
Because they have a different culture around what it means to be private. In Iceland, people's personal income tax returns are public documents. You can go online and look up the income tax return of your neighbor. Imagine that in the U.S. I mean, I can't imagine that in the U.S. So there are all these various differences, but I think there's both the short-term safety, is it safe enough to be used now, where you're going to have to pick a follow-up period and say, well, we'll watch for a year before we make a decision, or we'll watch for 2 years. And I hope and trust it will go through the normal FDA process of phase 1 trials, small trials looking at gross safety, but only in humans after it's been done in non-human animal models. For this, probably non-human primates, in order to feel maximally confident. Then phase 1 with a small number of people watch them for a while. Then phase 2 with more. Then phase 3. And at some point, probably 2 to 4 years after you've started the clinical trial process, if the data looks good, you say, okay, this is ready to be used clinically.
As much as we get excited about animal models and what's going on in mice, as you mentioned in the book, we can cure every disease in mice and we can't cure it in people. So there's a lot that doesn't quite apply when we're trying to talk about whether something that works in one species would be applicable to us. And there's challenges to try and do any sort of animal research once we start talking about those other ones too.
It's cloning was a nice example of this. It turned out that reproductive systems, even in closely related species, were so different. Cats turned out to be really easy to clone. Dogs, fellow members of carnivora, turned out to be really hard. Mice were really easy. Rats were really hard. Hamsters, which have been used for all sorts of research over the years, turned out to be really, really hard. Even closely related species are very different. So we probably would not do research in chimps, though they are the most closely related species to us. And I think I could make an argument for it, but I don't think it would win. We'd probably end up using macaques, monkeys. Are they closely related to us? Well, yeah. How confident should we be in the results? Well, not very. If the results turn out terrible in macaques, that's a pretty damn good reason not to try it in humans. If they turn out well in macaques, that gives you some confidence, but it is by no means a guarantee. So I do think, though, that the drive here from all the people who want to have genetically related children is going to be so strong that if it biologically is possible and produces good results, even if they're not perfect results, I think this is likely to happen. And actually, I want to go back to something you said earlier, Anne. You being a healthcare professional and me being a lawyer, maybe we look at this sort of differently, but you said, yeah, it'd be great for society to have fewer people with cardiovascular disease or Alzheimer's or other issues. And yes, preventing human suffering is a good thing. The lawyer in me says, yes, but especially in countries where they're paying for everybody's healthcare costs, not having to pay for Alzheimer's disease care or cardiovascular care, even if you are the Scroogiest of Scrooges, if you don't care a bit about human suffering, saving a bunch of money, yeah, I know a lot of people who would think that would be a good thing. So ultimately, one of the book's arguments is this will be free. It won't be free in the sense that it won't cost anybody anything. Everything has some costs, but the costs will be paid by the healthcare system. And I use an absurd example. Anytime you try to predict healthcare prices or costs, which of course are also two very different things, costs versus price. Even today, good luck. Projecting them 30 years in the future, you've got to be an idiot even to try it, but I did it anyway. And I said, well, so let's say it takes $10,000 to make one of these babies. And you make 100 babies. That's $1 million. Well, how many births of babies with serious genetic diseases do you have to prevent in order to save $1 million? And the answer is about 0.3.
As you say, well less than 1 in terms of the lifelong healthcare costs.
And about 1% to 2% of all births in the U.S. and around the world are children with a serious genetic condition that could have been seen through pre-implantation testing.
And that's even the testing that we can do right now, not even getting into that theoretical whole genome sequencing. Our limiting factor right now is our ability to create embryos to test. We often end up with a situation where we don't find an embryo that is unaffected and chromosomally normal. And then people try again and again if they have the funds to do so,
Right.
Or many people aren't able to go that route. And you're right, there's a very strong desire for many people to, if they can, have their own genetic child. And we get asked this commonly, especially if women are in their later reproductive years. And again, that egg, both number and quality that we can obtain, is the limiting factor. And there are already people for years have been peddling that they have some magical treatment that will make your eggs be young again. And that has not been shown in the research to be happening, but that's what people want. And people fly all over the world right now for experimental therapies that promise to make older eggs act young again. And this would be, a way of bypassing that and just making a lot of them from other cells in the body.
I think the only thing those treatments are strongly correlated with is increased credit card debt.
Yeah.
And it is a frustrating thing about this mitochondrial transfer. So mitochondria are the little bitty DNA circles that the energy powerhouses of your cell, the mitochondria, have that are kidney bean shaped. I didn't know what kidney beans were until I took high school biology and saw a picture of a mitochondria. And, oh, that's a kidney bean. Gosh, I wonder if kidneys look like that. And they do.
Yeah.
There are diseases of that. That's like 16,000 base pairs of DNA. Compared to the 6 billion base pairs in our cells' nucleuses. But there are diseases that can be caused by that, and any woman with a mitochondrial disease will have children with that mitochondrial disease, almost always, because the kid's mitochondria come only from the mother. All the mitochondrial diseases, thankfully, are pretty rare, but you could, in theory, treat them by swapping the mitochondria out, getting an egg that has the person who wants to be the mother's nucleus and those 6.4 billion base pairs, and putting in mitochondria from somebody else. this is being done. It's been done in Greece. It was being done in Ukraine before the invasion. But what drives me crazy is, in a lot of cases, it's being done to try to enhance the fertility of old eggs.
Yeah.
And that's based on a very plausible story. Mitochondria are energy powerhouses. Old eggs probably lack energy. Let's give them better energy. But there's no, as far as I can tell, there's no good evidence that that's actually true. But it's a great way to separate desperate people from their money.
Mm-hmm.
Sure.
Very much so.
Which is part of why I believe so strongly in the importance of the FDA. FDA can be mind-numbingly bureaucratic and annoying and slow things down. And your field has largely avoided FDA in many respects. But at least with FDA, you know that somebody has taken a hard look at safety and efficacy, and that what's being sold is not quackery. We know that IVF is not quackery because there are 10 million babies, 10 million people around the world who are the product of it. But for so much in the medical world, unless it's gone through controlled clinical trials, I don't believe it.
I know we're getting a little bit towards the end of time, but I want to ask you, since I had a lot of fun reading your book and reading the legal chapters and thinking, I wonder if he wants to rewrite these, like post Dobbs decision. How do you think that would change your predictions? Do you think no longer having kind of this reproductive protection when it comes to privacy in terms of what the states might do to regulate, do you think that makes it less likely that we would kind of move in these directions? Or how does that change your predictions?
It's actually published a paper about embryos, ex vivo embryos, after the death of Roe last year in the Journal of Law and Biosciences. I don't think it's going to affect IVF much, if at all, because IVF is popular. Even right-to-life people like IVF because it produces babies for people who want to have babies.
They like IVF, but they don't like discarding embryos.
No.
So if you had a system where you made 100 embryos, that's a pretty big thing.
That's true. And yet, even though restrictions on embryos were never prohibited by Roe v. Wade, only one state has laws requiring or restricting destruction of embryos, Louisiana.
I know. Shout out Louisiana. We've mentioned it in multiple different podcasts.
But there are still IVF clinics in Louisiana.
Yeah.
The cost, the discounted net present value of the cost of keeping an embryo frozen potentially forever is a tiny fraction of the cost of IVF. You do get weird things like rescue boats being sent to rescue frozen embryos in the middle of Hurricane Katrina, which actually happened.
Yeah.
The first child born from one of those frozen embryos was named Noah, which I thought was, I don't know whether I thought that was a good thing or a bad thing, but it was certainly an interesting thing. I do think there will be more efforts to restrict embryo research. I think there will be efforts to restrict embryo use and embryo destruction in IVF, but I don't think those will succeed. Not as a matter of law, but as a matter of politics. Because IVF gives people babies. Almost everybody wants people who want to have babies to have babies. The people who are going to use IVF maybe have particular political clout because they have money. I think one of the great scandals of IVF in America is it's a way, a new form of eugenics. Poor people who need IVF can't reproduce because we don't pay for it. So the people who can use IVF will have money, which means political power. Lots of political power lies in older people who aren't going to be using IVF themselves, but who want IVF grandchildren.
I would say they sure want their grandkids.
Yep. So I think IVF will be safe. Now, easy PGD will be trickier. And I do think it won't be adopted in every country. Germany has a lot of reluctance around human genetics for good reason. On the other hand, places like Singapore are actually pretty excited about eugenics. California, I'm sure, in 40 years, who knows how politics will change, but California will embrace this. Would Mississippi or North Dakota? I'm less certain, but particularly, and I think we will see a test of this post-Dobbs, the ability to travel across state lines for reproductive services. I don't think anybody's going to be able to restrict that, either as a constitutional matter or, more importantly...
Well, Texas is sure going to try.
Well,
We'll see.
Yeah, good luck to them. More importantly, as a practical matter. What are they going to do? Search every woman who comes across the border looking to see if there's signs that she had a recent abortion? And search every woman crossing the border to see if she had a PGT embryo implanted or transferred? So I don't think it's going to make much difference. In fact, we are recording this on Monday, November 6th. Tuesday, November 7th, it's going to be really interesting to see how Ohio votes.
Ohio, yeah.
On a big abortion question.
Well, that actually, I don't think it's too much off topic because it brings up the issue of morality, which we've been talking mostly about the science today. And so the ethics of it can go in multiple different directions with each step of the way. So just the Dobbs decision has kind of shined a light on all the different aspects of reproduction that we might not have thought about before. It would be an argument.
And if we think about it from that big picture society paying for healthcare and saying that there's this incentive to not have children born with genetic diseases, if you're talking to, children that have a genetic disease that are living potentially a life that is different than we would have expected, maybe a shortened lifespan. But most of the time, if you're that person, you don't want to be told that your life wasn't worth living, or that that the government or whoever's going to do it is going to tell you which lives are valuable. That brings up a lot of morality issues.
Yeah, ultimately, I come down somewhat reluctantly on the side of parental choice. Let the parents decide whether not just what disease risks their children will bear, but if they want to choose something, if they want to make a decision based on hair color, which seems to me really silly and dumb, I would rather have parents make that decision than have a legislature decide that parents can never do that. And, for example, if you've got 5 embryos who are tied on all the health issues, well, why not use eye color as a tiebreaker? But if somebody really wanted that as the only reason, that would strike me as dumb. But overall, I think that parents are more likely to have the best interests of their children at heart than the government, even though clearly there are times that's not true. We have child protective services for some good reasons, but much of the time it will be true. I don't think anything about this is going to be universal. I think some countries will encourage it, some countries will discourage it, some countries will ban it. It's possible that some countries will try to make it mandatory, although whether they can pull that off or not, I don't know. Some couples will say, great, we can have a healthier baby. And I think the selling point for most people will be, here's 6,000 really nasty genetic diseases. We could predict and avoid these 6,000. The good news is they're all rare. The bad news is when you multiply rare times 6,000, you get about 1 to 2%. So if you do this, you can avoid that 1 to 2% of having a child with a terrible disease. Some people will say, yes, of course. Why in the world wouldn't I want to do that? And others will say, no, I think it's only right to let nature or God or chance take its course. Or it's just so romantic, so much more romantic to make babies the old-fashioned way, or whatever. People will differ. The older I get, the more convinced I am that, people are different, and they've got different hopes and fears and desires. And it's not very often that I feel comfortable saying, that's really unreasonable, because people have very different and yet reasonable aspirations and views about what their life and their family life should be.
I wanted to read, I love one of your final concluding points when you said, I believe quite deeply in things that almost all of my ancestors only 250 years ago would no doubt have found appalling. What things do I believe today that my grandchildren, let alone great-great-great-grandchildren, will view as bizarre? The word of 50, 100, or 200 years from now will be their world, not mine or yours. They should have the right and power to run it. And I feel like that's a beautiful sentence. And also, when I was reading it the first time, I thought you said that they should have the right and power to ruin it. And I thought, wow, that's deep. And then I thought, gosh, I kind of like it either way because it's true. It's not our world anymore.
Well, the right to run is the right to ruin.
Yeah, exactly.
Thomas Jefferson actually early on said he thought that the Constitution should change every 30 years. Every generation should write its own Constitution. And in a way, it does. Our world changes. We don't own it. We rent it. We are in it for a brief period. We are connected by friendship and by blood and by DNA to people who came before us, and many of us, all of us by friendship, but also for many of us by DNA to those who will come after us. And the world does not stop. It does not exist only during our lifetimes. So nothing we do, we should consider permanent, because it won't be.
That's a perfect place to end.
Thank you so much. This was just an amazing conversation. I so appreciate you coming and sharing your time. I hope people will check out your book, especially anyone that's interested in these topics, because you do a great job of making the information accessible and interesting.
Well, thanks so much, Ruby and Anne. And Anne, I particularly want to thank you. I think you may have read my book more carefully than I ever did.
Ruby and I are doing the homework. That is our thing.
Okay. Well, I've enjoyed this very much. Thanks for having me on.
Thanks for joining us for this week's episode of the Whole Pineapple Podcast. We hope it was helpful.
If you know someone who could benefit from hearing the podcast, we hope you'll share it with them.
And don't forget to subscribe, rate, and review the Whole Pineapple on your favorite podcast app. Every rating and review makes us easier to find.
This podcast is sponsored by Seattle Reproductive Medicine and is produced by Audiotocracy Podcast Production. We'll see you next time. Have a delicious week.